Okay, so we are on Unit 6, Lesson 2, which is solving logarithmic functions. So now what we're going to do is we looked at how to expand logs, we learned how to condense them, and now we're going to learn how to actually solve them. Okay? So if they're the same base, then all you're going to do is you're just going to take the exponents and you're going to equal them. So here we've got 4 3 to the 3x equals 8 to the x plus 1. Now as you can see, one base here is 4 and the other is 8. So we need to make these two bases equal to each other. So we figure out what two numbers does 4 and 8 have in common, and that's 2. So we're going to break 4 down into 2 times 2, which becomes 2 squared. And then we're going to break 8 down to 2 times 2 times 2, because 2 times 2 is 4, times 2 is 8. So that becomes 2 to the third. So then you just put in parentheses your 3x and put in your other parentheses x plus 1. You're going to go ahead and you're going to multiply that. So we've got 2, 6 to the x equals 2, 3x plus 3, because you just distribute in. And now we're just going to make your exponents equal to each other to find out what x is. So 6x is equal to 3x plus 3. So you subtract 3x from both sides, and you get 3x equals 3. You divide by 3, and you get x is equal to 1. Now let's do example number 2. Again, we've got bases 2 and 32, and we want them to be the same. So let's just go ahead and use 2 as our base. So 2 to the 4x, and then 32, let's break that apart. So 32 is 8 times 4, which is equal to 2 times 2, and 4 is equal to 4 times 2, and then 2 times 2. So 32 is 2 to the 5th power. So 4x equals 2, put your 5, and then you take your x minus 1. Again, we just want to deal with our exponents. So 4x equals, go ahead and distribute, 5x. So we're going to distribute here. So 5x minus 5. Okay, so 4x equals 5x minus 5. You're going to add 5 to both sides. Then you get 5 plus 4x equals 5x. Subtract 4x, and you get x is equal to 5. Now let's look at example 3. Again, you've got 9 and 81. Both those have 3 in common, so 3 to the second is 9. So 3 squared times 2x, and 81 is 3 to the 4th. So 3 to the 4th is equal to 81. So 3 to the 4th times 3x minus 2. We're just going to deal with our exponents. So 4x equals 12x minus 8. So we're going to add 8 to both sides, and you get 4x plus 8 equals to 12x. You're going to subtract 4x, and we get 8 equals 8x. You divide by 8, and you get x is equal to 1. Now we're going to go down here, and we want to, basically what we want to do is we want to make again, we want to make our bases the same. So here we've got 2 to the x equals 7, and that equals 2 to the 7th, which equals to x. Now remember, if we've got 2 to the 7th, then 7 is on the top. So log 7 divided by log of 2 is equal to x. Okay? All right, we're going to go over here. We've got 10 to the 2x minus 3 plus 4 is equal to 21. So we're going to subtract 4 from both sides, and we get 10 to the 2x minus 3 is equal to 17. Now again, what this looks like, we want to change it into log form. So this, remember, 17 is your base. So we've got log of 17 is equal to 2x minus 3. And log 10, we just ignore the 10, and it's just log of 17 is equal to 2x minus 3. So we're going to add 3 to both sides, and we get log of 17 plus 3 equals to 2x. You divide by 2, and you get x equals log of 17 plus 3 divided by 2. Okay, let's go down to example number 6. We have 5 to the x plus 2 plus 3 is equal to 25. We're going to subtract 3 from both sides, and we get 5x plus 2 is equal to 22. Now we want to, this is exponential form, we want to change it into log form. So this reads 5 is your base. So log of 5 to the 22 equals x plus 2. So we are going to subtract 2 from both sides, and we get log of 22 divided by log of 5 minus 2 equals to x. And remember, log of 2 divided by log of 5. So here we've got 4x is equal to 15. That's just log of 4, 15 equals to x, because 4 is your base and 15 is your exponent. Okay? So last, we're going to go and we're going to solve log functions with the base being the same. Okay, again, log 3 and log 3. Our base is the same, so we don't need to change it. Okay? So we just deal with our exponents. So 5x minus 1 is equal to x plus 7. You're going to add 1 to both sides, and you get 5x is equal to x plus 8. You're going to subtract x. You've got 4x is equal to 8. You divide by 4, and you get x is equal to 2. Down here, log of 4 and log of 4, we don't need to change our bases. So x plus 3 is equal to 8x plus 17. You're going to subtract 3 from both sides, and you get x is equal to 8x plus 14. Okay, you're going to go ahead and you're going to subtract 8x. You're subtracting 1x from 8x, so it becomes a negative 7x, which is equal to 14. You're going to divide by a negative 7, and you get x is equal to a negative 2. Okay? Now, Now we're going to solve log functions, but now you have log of 5 times 3x plus 1 is equal to 2. So what you want to do is you want to get rid of this log here. So what you're going to do is you're going to add a 5 in front, which cancels that out, but what you do to one side, you've got to do to the other side. So this is you're going to add a 5 to the front, cancel that out, and you're going to add a 5 to the front here on the other side. So you've got 3x plus 1 is equal to 5 squared. So 3x plus 1 is equal to 25. You're going to subtract 1. 3x is equal to 24. You're going to divide by 3. And x is equal to 8. So over here, the same thing. You want to get rid of your log 5. What you do to one side, you have to do to the other. So you're going to add a 5 to get rid of log 5, but you got to add it to the other side. So x minus 4 is equal to 5 squared, which is 25. You're going to add 4, and x is equal to 29. Okay, so again here we've got log of 4, x plus 3 is 2. We want to get rid of this log 4 to go ahead and solve. So we're going to add a 4 in front, but what we do to one side we have to do to the other side. So we're going to add a 4 to get rid of log 4, and then we've got 4 squared on the other side. So x plus 3 is equal to 16. You're going to subtract 3, and you get x is equal to 13.